Hello everyone, and thank you for being here as I walk you through the decisions I made while creating my infographic. My topic is snowpack loss and water conservation. With the hotter temperatures we've been getting over the years in general, it has been negatively affecting the snowpack level at the Cedar River watershed, which feeds the greater Seattle area. It's important for citizens to understand how this is happening and what they can do to conserve water if they need to. For my title, I went with Snowpack Loss and Water Conservation. Simple, to the point. If you read it, you know what this is about. My opening text are several sentences that one of my fellow students gave me an idea to write. My original opening text was long, verbose, wandered a little bit. These two sentences really help push my point on learning some simple water conservation tricks and why you should care about the snowpack loss. Going into the infographic itself, you can see that all of my subtitles were all underlined. This is so that people understood where the subtext was and where each of the different areas are. My first graph is a line graph that shows snow water equivalent levels at Tinkham Creek with a trend line. Snow water equivalent is the water content obtained if all snowpack at a location melted instantly. This gives a better understanding of how much water is in a snowpack when compared to snow depth. When snow falls, depending on what kind of snow it was and how it fell, it can lead to people overestimating or underestimating how much water is in there. So it's important for the data to show how much water is at this level instead of just the depth. I decided to choose a 30-year time span because I felt that it would be long enough to show the data accurately without running out of data. The further you go back, the less reliable data there is, and you can just run into more problems associated with old data. The second graph I did is a column graph showing temperature at Tinkham Creek. The temperature was taken from August, while the snow water equivalent was taken from March. In March, you're generally not going to get that many more snow events, so the level should be about the max it will be. And in August, it's not going to get much hotter, and it'll start cooling off going into September, so I felt like it was good to choose both the highest level of snowpack and the highest temperatures. The temperature color itself was chosen because blue, I felt, represented the color of the snow and the water that I wanted to represent, and the yellow, orange, and red colors all correspond to a U.S. Drought Monitor Index level. Yellow is abnormally dry, orange is moderate drought, and red is severe drought. If you'd like to learn more about what each of these mean in detail, please visit the U.S. Drought Monitor website. I did not have the space to go into each of these colors and what they represent beyond labeling them. As you can see, this is also a 30-year time span, although the U.S. Drought Monitor website did not have data for King County going back before the 2000s. Going on to my third graph, we have a pie chart. This is water use by type. The average American uses about 300 gallons a day, with 70% used inside and 30% used outside. I wanted to show how much water people use because it's important to understand just the sheer quantity that we use. This is the average American household, so that means half could use more and half could use less. I went with blue because I've used blue throughout most of this. I felt like it was a nice neutral color that would stand out without standing out too much. I really wanted to make the 30% outside more of a problem because that's where one of my proposed conservation ideas is. Drought statistics. 18 out of 24 of the past years have been at some level of drought warning. This also corresponds with the previous graph, so if you move directly down, you'll see this. Now, looking at the layout of these two graphs, a pie chart and a visualized number, you can see that I sort of had, I went a little bit across, and sort of split it down the middle, where this had more text on this side, and this one took up more space over here, and this one took up less space, and this one also took up less space. Moving on to conservation. I talked about how you can save some water pretty easily by just showering slightly less. You can reduce your water usage by 2% just by showering for 1 less minute per day. This isn't anything crazy. It's not telling you to stop showering or anything like that, and not telling you to renovate your bathroom or get new water-saving tricks or anything. It's just slightly less time would save 2% water, which is a whole lot for only changing the time, not any of the materials, equipment, psychology, any of that. My big issue that I was focusing on, especially with my isotype, was outdoor lawns. In the Pacific Northwest, it's recommended that you water 4 times over the summer if you want a dormant lawn, and up to 20 times if you want to actively use your lawn. I chose to represent the amount of water used as 100 Olympic swimming pools. Olympic swimming pools, everybody's pretty much seen a swimming pool, and if they imagine an Olympic one, they know it's really big. So they can picture that. It is a feasible amount of water to picture. When you get to big numbers like 1 billion gallons of water, it's really hard to picture that. You'd have to start talking about lakes or stuff like that, and those big quantities can just get really hard to picture. We also use sizes of sporting event centers to represent a lot of our lengths. By a football field, by a football pitch, it's X number of yards, it's X number of football fields long. By using Olympic-sized swimming pools to represent the amount of water, you can really just imagine, each Olympic swimming pool picture represents 100, and it goes from 20 down to 4. So you can just really imagine how much less water you'd be using if even half the people switched from 20 times per summer to even 10. That would still cut it in half. Going on to my conclusion, I just wanted something simple. Now you're more aware of how you can conserve water if needed. I added my sources at the bottom. Going over all of my points again, snowpack loss and water conservation. I had less text. I had more text here, less text, more, less, more. And then I centered my outdoor lawns somewhat, and then did text, and then centered my conclusion. This has been my walkthrough of my advanced technical writing infographic. Thank you.